Hello and welcome to the Daily Space for today, Tuesday, November 10th, 2020. I am your host, Dr. Pamela Gay,
And I am your host, Beth Johnson.
and we're here to put science in your brain. And today's science is largely radioed in from all around the world. And it starts out with what appears to be the first identification of an object emitting fast radio bursts. First discovered in 2006, these fraction of a second events bundle together the energy of 3 days worth of sunlight. They come in various styles, ranging from the random single detection to recurring systems that exhibit periods of bursts and periods of quiet. It has been suspected that some kind of a compact object, a neutron star or black hole, could be the source of the bursts. But because they had always been detected in distant galaxies, these theories hadn't been grounded in a lot of observations. At least not until now. On April 27th, the Swift Orbiting Observatory detected a storm of X-ray bursts associated with the SGR 1935 plus 2154 magnetar. This spinning neutron star is known to have a powerful magnetic field that releases X-ray and gamma ray light in association with changes in its structure. Starquakes and other events that occur as this young neutron star settles into equilibrium can create storms that last for hours or even days. The April 27 storm lasted for hours, with X-ray bursts that lasted less than a second being detected by Swift, Fermi, and NICER. But 13 hours after the system had quieted down, and while all these orbiting observatories were on the wrong side of the planet, SGR 1935 plus 2154 let off a half-second long burst of incredible brightness that was caught by ESA's Integral, Russia's CONUS, and China's Huyan missions. As the spacecraft detected this final massive X-ray burst, ground-based radio telescopes, CHIME and STARE-2, caught a single radio burst that, like a fast radio burst, lasted just a thousandth of a second. These results appear in a pair of papers in the journal Nature, and co-author Paul Schultz explains. The radio burst was far brighter than anything we had seen before, so we immediately knew it was an exciting event. We studied magnetars in our galaxy for decades, while FRBs are an extragalactic phenomena whose origins have been a mystery. This event shows that the two phenomena are likely connected. The energy of SGR 1935 plus 2154 is consistent with how weaker FRBs would appear from other galaxies. Um, if this was a local FRB, then we can expect other FRBs to also have associated X-ray activity that is simply waiting to be discovered. We now just need more magnetars in our galaxy and nearby galaxies to, well, do their flickering and flaring thing so that we can catch them dancing across the electromagnetic spectrum.
Not everything this week is brought to you courtesy of radio telescopes. Space science can involve fieldwork, too. High in the Atacama Desert in Chile, scientists continue to study the extremely arid region as an analog to Mars. And last week, researchers at Cornell and Spain's Centro de Astrobiología published a paper in Nature Reports where they have given us a potential primer in how to look for microbial markers in the soil of Mars. The soils in the Atacama are clay-rich, and at shallow depths they contain a diverse population of microbes. It involves a layer of wet clay about a foot down from the surface. As corresponding author Alberto G. Ferren explains, the clays are inhabited by microorganisms. Our discovery suggests that something similar may have occurred billions of years ago, or it may still be occurring on Mars. If there were microbes on Mars in the past, there should still be evidence or markers of those microbes in the soil. Several rover missions are scheduled to land in the coming years, including NASA's Perseverance, which is specifically designed to look for those markers. This researchers gives those rover teams a guide for where to search and what to look for in the Martian clays. Per the press release, The researchers' Atacama discovery reinforces the notion that early Mars may have had a similar subsurface with protected habitable niches, particularly during the first billion years of its history. Life really does find a way, y'all. Here's hoping we find evidence of it on the red planet.
While not all today's news comes to you from radio telescopes, most of it comes from radio telescopes. These giant dishes can conveniently work day or night, and thanks to our ability to easily combine multiple telescopes of data into a sprawling virtual telescope, they allow the highest resolution images of our universe. We take advantage of radio dishes to do everything from imaging distant supermassive black holes to watching aurora flicker in the atmosphere of Jupiter. Well, we've known for some time that giant planets and small stars can warmly emit radio waves. Discovering these kinds of objects has generally been left to the infrared observatories, with radio telescopes stepping in to do the follow-up work. Well, as you may have noticed, we're currently short on infrared observatories, with Spitzer retired and, well, JWST hasn't launched yet. And while infrared and even optical telescopes can spot warm brown dwarfs and planets, cold ones will be too faint to generally be seen. And cold lone objects may be some of the more interesting objects out there. In a new radio survey, the LOFAR radio array was used to search for objects too cold and faint to be seen in existing infrared surveys. Objects found in this survey could then be observed with large scopes like Gemini or IRTF and identified. One such pinprick of radiolite came from an object designated BDR J1750 plus 3809, which was conveniently dubbed L-Glast. It was named this by the LOFAR team. This is the first non-extragalactic object to be discovered in the radio, and it was determined to be a brown dwarf star. The way they did this is actually kind of cool. Light from an individual star or planet will have a specific polarization. This is a fancy way of saying the light waves are oriented in a measurable way. Galaxies, which are made of many different objects with light oriented in many different ways, don't have the same kind of polarization. To separate the distant galaxies, radio scopes are so good at detecting from nearby tiny objects they aren't generally used to detect. The research team just looked for objects that had polarized light. According to team member Joe Callingham, with LOFAR, we want to go down the mass ladder all the way to Jupiter-like planets that are too faint to have been found in existing infrared surveys. So we decided to search for these objects directly in our radio images. This work appears in the Astrophysical Journal. In looking at the object with multiple scopes, they were able to determine it is consistent in makeup with our system's gas giant Jupiter. According to co-author Harish Vandatam, the Gemini observations told us that the object was cold enough for methane to form in its atmosphere, showing us that the object is a close cousin of solar system planets like Jupiter. This is a new technique being used to do new and awesome things. And I, for one, look forward to seeing what can be discovered in this long wavelength of light.
Oh, hey, look, a Bennu story. Unless you've been living under a rock, and frankly, the way this year has gone, who could blame you? You know the OSIRIS-REx mission snagged a sample of Bennu's surface last month. Well, that sample is not the only work being done in regards to Bennu and its history. Using all those images and the resulting rock maps you helped with, scientists at Southwest Research Institute have taken detailed measurements of centimeter to meter-sized craters in some of those bigger boulders we saw. The goal was to understand more about the age of Bennu. A reminder for those new to our show. Bennu is a rubble pile asteroid. It's held together by gravity, barely, and could be the remnant of a larger asteroid that was hit by a bigger object. It actually has a lot of impact craters, albeit smallish ones, scattered across the surface, and these are most easily seen in those boulders I mentioned earlier. They are not easy to see, however, as our citizen scientists found out the hard way. So, the team at the University of Arizona developed a mathematical method to calculate how much of an impact a boulder of any given size and strength could handle without being broken apart. The result? The teams, quote, brought together an understanding of the number of craters, the strength of the materials impacted, and the number of impactors to help constrain the chronology of Bennu's existence in the inner solar system at 1.75 million years. So Bennu hasn't been in the inner solar system long at all. Of course, we'll have to wait for the sample return to arrive in 2023 to gain any further understanding of Bennu's age and composition. I suspect we'll keep hearing about our favorite asteroid to hate as institutes attempt to keep the OSIRIS-REx mission in the public eye, now that the sampling portion of the mission is done.
Sometimes science gives, and sometimes, well, reality takes. In our next story, we once again go to the radio. And with this story, we have bad news from Arecibo National Observatory. The massive dish built in Puerto Rico had another support cable fail. As we reported in an earlier episode, on August 10th, an auxiliary cable failed and in the process damaged an instrument and several panels in the dish. While the damage was minimal, repairs have been slowed by COVID and other issues such as hurricane season. While those repairs remain incomplete, the other cables in the system have carried a larger load than normal, and one of the main cables simply failed on Friday. Ironically, repairs on this initial damage were scheduled to start this week. According to Observatory Director Francie Cordova, we have been thoughtful in our evaluation and prioritized safety in planning for repairs that were supposed to begin Tuesday. Now this. There is much uncertainty until we can stabilize the structure. It has our full attention. We are evaluating the situation with our experts and hope to have more to share soon. Arecibo is managed by the University of Central Florida, who said in a released statement that the team hopes to be able to reduce the tension in the existing cables at the tower and install steel reinforcements to temporarily alleviate some of the additional load that is being distributed among the remaining cables. Experts are being mobilized to do the work as quickly as possible. The team will attempt to expedite the arrival of 2 new cables that were already on order. Repairs aren't cheap, and their current funding can't cover all of their needs. Currently, Arecibo has a request into the National Science Foundation to cover the initial repairs, and I anticipate that request being increased to deal with this new reality. After watching this facility face numerous cuts across the decades and hearing NSF threaten to, cut its funding more than once, I truly hope these accidents aren't a death knell for this historic and still powerful facility that can both do radar imaging of asteroids and detect faint radio signals from objects near and far.
Well, that sucked. Everyone take a deep breath and look at the beauty of Europa and my cat. Europa glows, not the cat. No, literally, it glows. You see, Jupiter is constantly zapping Europa's surface night and day with high energy radiation, such as electrons and other particles. And those high energy particles are making the surface of Europa glow in the dark. This new research from NASA's Jet Propulsion Laboratory details what this glow would look like. Per the press release, it could reveal about the composition of ice on Europa's surface. Different salty compounds react differently to the radiation and emit their own unique glimmer. To the naked eye, this glow would look sometimes slightly green, sometimes slightly blue or white, and with varying degrees of brightness, depending on what material it is. Usually, scientists take spectra of an object to determine its composition. Of course, you need sunlight to use a spectrometer, which means taking the measurements on Europa's day side if we want to know what the ice is made of. Now we can talk about how Europa looks in the dark. JPL's Murthy Gudipati, lead author of the new paper published just yesterday in Nature Astronomy, explains, "We were able to predict that this night-side ice glow could provide additional information on Europa's surface composition. How that composition varies could give us clues about whether Europa harbors conditions suitable for life." In case you weren't aware, Europa is a strong candidate for finding life elsewhere in our solar system because it has a massive interior ocean of liquid water. And scientists are primed to understand that subsurface ocean as much as possible. Per the press release, scientists have inferred from prior observations that Europa's surface could be made of a mix of ice and commonly known salts on Earth, such as magnesium sulfate, or Epsom salt, and sodium chloride, table salt. The new research shows that incorporating those salts into water ice under Europa-like conditions and blasting it with radiation produces a glow. To be honest, that part of the story isn't a surprise. Where this research broke a little new ground is best explained by co-author Brianna Henderson. When we tried new ice compositions, the glow looked different. And we all just stared at it for a while and then said, "This is new, right? This is definitely a different glow." So we pointed a spectrometer at it, and each type of ice had a different spectrum. And here is where a fantastic NASA acronym comes in. The team used a new instrument called the Ice Chamber for Europa's High Energy Electron and Radiation Environment Testing, ICEHEART, and did experiments with high energy electron beams. As co-author Fred Bateman pointed out, seeing the sodium chloride brine with a significantly lower level of glow was the aha moment that changed the course of the research. So while our moon glows from sunlight, Europa glows from sunlight and the radiation of Jupiter. It's possible that the upcoming Europa Clipper mission could detect this glow, and the instrument team is determining that possibility. If that's the case, the spacecraft could match its data with the measurements in this research to identify salty components on the moon's surface and narrow down what they might be. It will be a bit of a wait, but I think it will be worth it.
And to give you one final bit of cheer, we are pleased to share that the iconic Parkes Observatory in Australia has gone on a telescope naming spree. Working in collaboration with the Aboriginal peoples of the local area, the Wurundjeri people, they have chosen traditional names for the scopes that allow them to connect the historic instruments with cultures of one of the oldest societies in the world. This was done as part of Australia's Reconciliation Action Plan, which looks to recognize the knowledge and traditions of the Aboriginal and Torres Strait Islander peoples. The new names for the scopes are as follows. The 64-meter Parkes radio telescope has been named Miriam. In the Wurundjeri dreaming, Biryami is a prominent creator spirit and is represented in the sky by the stars which also portray the Orion constellation. Miriam represents the sky world where Biryami lives. The 12-meter ASCAP testing antenna has been named the Giyal Mill, meaning smart eye. This telescope was commissioned in 2008 as a test bed for a special new type of receiver technology, a phased array radio feed, used on Cicero's Australian Square Kilometre Array Pathfinder antennas. The PAF is able to see different parts of the sky simultaneously, making it a smart eye. And finally, the decommissioned 18-meter antenna has been named Gi Ye Long Guluman, meaning smart dish. This antenna has the ability to move along a railway track while observing, and when linked to the main 64-meter antenna, became pivotal in early work that determined the size and brightness of radio sources in the sky. The antenna was originally assembled as part of the Cicero Flores radio telescope site in Perneath, New South Wales in 1960, and was transported to Parkes in 1963 and became operational in 1965. And with this press release, I'd like to make a quiet plea to any press officers working out there. When you give things amazing names, please include recordings of people who natively speak these languages pronouncing the names. Today, you're going to hear a myriad of radically different pronunciations of these different telescopes, as all of us around the world make our best guess at how these should be pronounced. We would dearly like to honor the peoples who have named these scopes, but right now we just don't know how. Nonetheless, we are pleased to see these names go to these historic instruments.
some heartwarming news this year. This has been the Daily Space.